Greetings and welcome. In today's lesson, we're going to look at using Cramer's rule as a means of solving systems. And our first example is going to be of a 2 by 2 matrix. And I'm going to solve the system, let's see, so 4x plus 5y equals 11. And our second equation will be 3x minus 2y equals -9. So currently we do have a variety of strategies, substitution, elimination, graphing. We could use inverse matrices, and Cramer's rule is going to be a type of matrix solution, except we're going to be relying primarily on determinants to do so. So what we're going to do is a few different things. The first thing we'll do is let's find the determinant of what I'll call matrix A, which will be the coefficient matrix, right? So the same one that we would use if I was solving using inverse matrices. So to find this determinant, it'll be 4 times -2, multiplying that diagonal, minus 3 times 5. And let's see, that's -8 minus 15, so -23. And since that's not 0, it's indicating to us that we'll have a single solution. So now what we're going to do is, I call this next one x sub n, which is my own notation. It's the x numerator, or the answer of my x numerator is what we do. And what we do is we're going to find another determinant, except the first column, the x's coefficient column from A, is going to be replaced with the coefficients. So we'll have 11 and -9 here, representing the x's column, and 5, -2, still from the coefficients for y. And when I find this determinant, I'll have 11 times -2 minus -9 times 5. So -22, double negative plus 45. Let's see, so I believe that's going to be positive 23. And so my x solution will come from my x numerator divided by the original determinant here. So it'll be 23 over -23, and I get -1. So this technique can be more efficient than, say, elimination sometimes, depending on what numbers I have. It's much more algorithmic, I guess, like where it's just a quick little formula instead of a whole process. So let's find the y numerator, and then we'll have our whole answer here. So the y numerator will be the same idea, except this time I replace the y's column with my coefficients. So the 4 and the 3 coefficients from the x's will be the same, and this time our constants from the right-hand side of the equation, so these two numbers here, will replace the y's column. And 4 times -9 minus 3 times 11. So let's see, so that's -36 minus 33. So that's what, -69. So that's my y numerator. So to find my y solution, it's just going to be the y numerator divided by the original determinant. So -69 divided by -23 will be +3. So our solution is -1, 3. So that's how you can do a Cramer's rule for a 2 by 2 matrix. And really the only trick to it is kind of recognizing that for the x matrix, you replace the x column, right, with the right-hand side, and for the y numerator matrix, we replace the y column with the right-hand side. and then you just find those determinants and can go from there. Once again, I just want to point out that if this, the original determinant was 0, then clearly when I tried to calculate these fractions, I would have had 0 in the denominators and I would have had an undefined answer. Let's see, I'm not going to do an entire example for a 3 by 3, but I just want to demonstrate the setup for it. So if I had, I'm just making up these numbers, 2x minus y plus z equals 1, x minus 5y plus 3z equals 2, and let's say I've got 3x plus y minus 2z equals 7. So I'd still be able to find the regular determinant for matrix A, and I'm just going to do the setup for this. We could use a graphing calculator to determine that. So 2, negative 1, 1, 1, negative 5, 3, 3, 1, negative 2, and then I'd find the determinant whichever way I need to, possibly by taking the first 2 rows and repeating them here and doing the diagonals trick, is likely what I would do if I didn't have a graphing calculator. Right, so we'd continue that. But in order to find the x numerator determinant, it's really thematically exactly the same. I will replace the x column with the right-hand side here. So I'd have 1, 2, 7, and all of the other numbers would be the same. So negative 1, negative 5, 1, and 1, 3, negative 2. And I'd be able to go from there to calculate the x numerator. And just to make sure we've got the concept, I'll skip the y numerator for now, and there's an n. And for our z numerator, the concept would be that we would replace the z column this time with the right-hand side, while the rest of the matrix would remain the same. So 2, 1, 3, and negative 1, negative 5, 1. So those 2 columns remain the same. Z column changes. And then y numerator, it would have been the same matrix as this, except the middle column would have received those. And I would find these determinants, and to find my x solution, that would just be the x numerator divided by the determinant of A. The value for z would be the z numerator divided by the determinant of A, and then y would follow suit. So Cramer's rule is kind of a nice, quick little technique. It's very formulaic, so it's pretty easy to follow, and thanks for watching the video. See you guys next time.